we don't need it just yet, but we are going to need it towards the end of class. So if you will go ahead and get that class kick opened up, it's not assigned to you in the course. Hey, Mia. It's just going to be for practice in today's live session, okay? Good morning, everyone. All right. Well, thank you all so much for coming. If you will go ahead and click on that link to get into the class kick, I can see most of you, yay, in there. So today we are going to talk about what you are learning in the course. You actually have a quiz in the course today over this. So I'm going to do my best to get through all of the transformations during this live session and give us some time to practice. However, I want you to take some time before you go and take your quiz, because in the course, there's quite a few videos that I've made for you. Some of them are short, like 3 or 4 minutes. So even though I think there's like 4 or 5, but take a look at those, take some time to just play those, ask questions. And then if you have anything, let me know. If you don't, then that would be great time to go ahead and take your quiz that's in the course. Okay, I'm looking right now. It looks like I have 1, 2, 3. Okay, there's 4 videos in there. So it's not too bad. But that's that. Alrighty, so let's go ahead and get started. Today we're talking about transformations to linear functions. Okay, so linear functions we know are straight lines. So let's talk about some vocabulary. The first thing I want to talk about is this top one called a family of functions. Okay, so this is a set of functions whose graph have basic characteristics in common. For example, all linear functions form a family because all of their graphs are the same basic shape, which is a straight line. Okay, so whenever you are given a problem from here on out, and it asks you, or it tells you, or it mentions a parent function, okay? The parent function is the most basic function in a family. For linear functions, the parent function is y equals x, or f of x equals x, because remember, f of x is another way to say y. Okay, so I'm going to show you on the next slide what this looks like. Then we have a transformation. So we have different types of transformations that we're going to go over today. A transformation is the change in position. So it's going to move up or down, left or right, or in size. So the slope can change. It could flip over an axis. So let's talk about this parent function. The parent function, again, is f of x equals x, or another way to write it is y equals x. So whenever we are going to graph this, we ask ourselves, okay, what is the y-intercept? What is the slope? Well, since it's just y equals x, that's the same thing as y equals 1x plus 0. So our y-intercept, or b, is going to be 0. That means this parent function, as you can see here, let me do it in blue. Okay, actually I can do it in red. Is going to start at the origin. All right, then we're going to use our slope. So in the parent function, the slope is 1. So it's up 1 and to the right 1. Up 1, right 1. Okay, so this line right here that goes through the origin has a slope of positive 1. That is the parent function. Okay, this is the function y equals x, or f of x equals x. So then what are transformations? Transformation is the graph of all the other linear functions are the transformation of the parent function. So a transformation starts with the parent function and we are going to move it somehow. So let me show you. For example, actually I'm going to cover some of this up so it's not so overwhelming. All right, so let's look at this problem. It says graph f of x and g of x. So f of x equals x. That is the parent function. Okay, so that's going to have a slope of 1 and a y-intercept of 0. Now, this new function, this is a transformation. Okay, so this is saying g of x, the new function, is the parent function x minus 5. So what we're going to do is we're going to graph the parent function and the new function g of x and see what happens. Yep, 1x minus 5. So it's not g of f, it's still g of x. Yep, good, Liv. So with our two equations here, our parent function is in blue. We've got f of x equals x. So our slope is 1. Our y-intercept is 0. For the new function, our slope is still 1, but the y-intercept is negative 5. So if we were to graph the parent function, that would be in blue. Okay, we start by plotting a point at the origin, or the y-intercept of 0. Okay, and then we're going to use our slope, up 1 over 1, up 1 over 1, up 1 over 1. Okay. Now, the next one, the red one, still has a slope of 1, but our y-intercept is negative 5. So we're going to be at negative 5 for our first point, the y-intercept, and then up 1 over 1, up 1 over 1. Okay, so these are parallel lines. We talked about that in our last lesson. These are parallel lines. Okay, so let's ask ourselves, okay, the parent function is in blue. The transformed function is in red. What happened when we subtract 5 at the end? The result is that the graph is shifted 5 units down. It's like if we took this blue graph and just slid it down. Okay, so this is a shift of 5 units down. So that's a really good question, RJ, sorry. Let me draw a box here to show you. Oops, there we go. All right, so if you have f of x here, okay, and you have the minus 5 outside the parentheses, it is going to go down. So what do you think would happen if I have f of x equals x plus 5? What would happen? Yeah, exactly. It's going to go up. Very good. So, Ben, Hey, Angel, we're just talking about math, okay? So, Ben, the difference between f of x and g of x is that they're two different functions. So, f of x means that we are going to, that's our parent function, okay? That is the blue line. Let me go back. This blue line, this is our parent function. Yes. G of x is just another name of a function. So we can't still use y because we already used y. So we're just using different names for functions. Okay, cool. All right, so now let's talk about let me go to, why is my mouse not going? Okay, here we go. Okay, in a linear, yes, I can go back to the very first slide or the one I was just writing on, like this one or this one. No problem, Adrina. The other one, oh, the parent function. Yes. This one? Yeah, you're welcome. So, yes, Ben, exactly. The parent function for linear functions is f of x equals x, which you're exactly right, also means y equals x. Yep, that's exactly right. Yay. Okay, so now let's take a look at, this is another rule. So this is another way to write the rule that we just learned. This is what we call when something is sliding up or down. We call this a translation or a shift. So it shifts up or it shifts down from the original. A vertical translation is made on a function by adding or subtracting a number to the function. So for example, if we have y equals x plus 3, that's going to be a translation up. If we have x minus 5, that's going to be a translation down. Okay, so you can use the word translation, you can use the word shift. Okay, either of those are totally fine. So what does this look like? The parent function is shown in red. Okay, our new function is y equals x minus 1. That's the function that we have in blue. So the transformation, if I had to describe it in words, we're going to get there, Maddie. Good question. This is a shift down 1 unit. All right. Now we're going to talk about, yeah, Erica, do you have a question? You have a question,
So,
Erica?
can you hear me?
I can.
So basically, if it says y equals like this example right here, or like it shows like another number in the problem, doesn't mean it's a vertical when it says what, like vertical translation if it says y equals, or is it just for f of x too?
Okay,
because in the
so
test it was kind of confusing when I took it for my first attempt and I got it confused.
okay, so the y and f of x are the same thing. So I'm not sure if that's part of your question, but y and f of x are the same. Usually what's going to happen is f of x is referring to the parent function. And on the quiz, I'm pretty sure we used like g of x a lot. So it's saying like, okay, g of x represents, so g of x is the new function. G of x represents the old function, f of x, moving up by 4 or down by 4 or to the right 4. Okay, so on the quiz, it uses g of x a lot. G of x is the new function. So this one would be, instead of y, it would be g of x. And your old function would be f of x. That's your parent function. So let's talk about how do we move, let's talk about reflections. So a reflection is like, think about a mirror, or if you're looking into a pond. Okay, a reflection on the x-axis. So if I think about my coordinate plane, this is my x-axis. So reflections are kind of, I don't want to say they're silly, but if we have a line, so let's take our parent function. Okay. Whenever we do a reflection on the x-axis, okay, we multiply by a negative number. So we're going to basically take this black line and flip it over the horizontal x-axis. Okay. So that one can be a little bit confusing. But what you need to know is that if your slope, your new slope is now negative, okay, that means that we have flipped it over the x-axis because it's a reflection. So we're saying, okay, we're going to take the old one and flip it in half. So this, wait, where is it? Let me work up here. This portion of the line is going to get flipped over. So now it's going to be up here. This portion of the line gets flipped over. Now it's down here. So we get this new function. Okay, so instead of having f of x equals x, we now have g of x equals negative x. Okay, so a reflection means your slope is now negative, and that is a reflection over the x-axis. All right, so Maddie asked about stretching a function. So a stretch is made on the parent function by multiplying the parent function by a number for x that's greater than 1. So if the number of the slope, actually, let me just write it out. I'll just put a text box here. That might be easier. If the slope is greater than 1, it is a stretch. And when we say stretch for linear functions, okay, this means that your slope is going to get steeper. Okay, because we're going to take this little line that we had and we're going to stretch it up, so it's going to become more straight up and down. Let me show you what that looks like on the graph. So that's a good question, Maddie. The slope is always the number in front of x. So let's look at this one. So our original function, parent function, is in red here. It's graph. So we'll say that that is f of x equals x. Okay, so in the parent function, Maddie, what is my slope in the parent function? It has a slope of, in the parent function, so our original function. The original function is f of x equals x. The slope of that one is 1. Yep, good, Liv. Ben, you don't need to worry about absolute value right now. All right, so my original function is the parent function, which is this red one that's graph. So I have my point that goes through the y-intercept, okay, or the origin at 0, 0. The slope is 1, so I go up 1 over 1, up 1 over 1, up 1 over 1. That's my original parent function. Now, next on my new line, g of x, my slope is the number in front of x, 2. 2 is greater than 1, so that means that the new function is stretched by 2. Okay, this is a stretch by 2 because it's bigger than 1. So now my slope is 2 over 1. Again, my y-intercept is still 0. So I start at 0, 0, and I'm going to go up 2 to the right one, up to right one. That's how I get my new blue function. Exactly. Good, Ben. So if your slope is bigger than 1, it is going to be considered a stretch. What if your slope is smaller than 1? We call it a shrink, or another word for it is called a compression. Okay, so we squish it down. A shrink or a compression is made on a function by multiplying the parent function by a number that is between 0 and 1. Okay, it's not any number less than 1, because negative numbers, a negative means we reflected it, but a negative 2 would still be a stretch of 2 and a reflection. Okay, so a compression is anything that is between 0 and 1. Most times it is fractions, okay, when obviously the top number is not bigger. So in this case, this is 1/2 x. 1/2 is between 0 and 1. So this would be a shrink or a compression by 1/2. So let's look at what that would look like on a graph. The blue line, the red line, let me write this in red. The red line is our original parent function. F of x equals x. Again, we start at 0, 0. We go up 1, right 1, up 1, right 1. The blue line is going to be our new function. Okay, we're going to call that g of x. So for g of x, I still have a y-intercept of 0 at this point. Okay, look at my slope. It's going to be 1 over 4. So that's going to be up 1 to the right 4. And that's where my point is. So that's my new line. Do you see how that is wider? It's like we took that line and we smushed it down and it started to flatten out. Okay, so that is called a compression, or if you want to call it a shrink, that's fine too. Yes, RJ. So there's 4 videos in the course. And I tried to split them up between each of these so that you could see some more example problems. There is one more thing we need to go over before we go to our practice one. So let me pull the whiteboard up real quick because I want you to see this chart. I'm going to post it for you. And then it's probably easiest to just take a picture of this. Yeah, that's exactly right, Angel. Stretch is where you're going to extend it. Your slope is going to be steeper. And a compression or a shrink is where you're going to flatten your line out. That's exactly right. Okay, I'm going to post this. Okay, so that's another really good question. Mia, that's actually the one we're getting ready to go over. So Mia's question is a stretch or a shrink in parentheses? So, for example, g of x, if your number, like let's say it's 1/2 x, let's say this 1/2 is in parentheses. If the slope is in parentheses, okay, that's okay. That's a stretch or a shrink. What you're asking about is what we're getting ready to go over. So Mia is asking, what if you have g of x? Yep, Ben, that would be a shrink. What if g of x is in parentheses x plus 3? So this is the new one we're getting ready to go over. G of x, that's just the name of the function, Angel. It's just telling us it's a new function. All right, so this g of x, this top one, 1 and 2, these are 2 different things. This top one, if you are adding something inside parentheses with x, this is actually going to be a shift left 3. Okay, I know that's like a little bit hard to believe, and I'm going to show you, and you can do it on your graph. Whoa, left 3. This one at the bottom, it's x and then plus 3 at the end, not in parentheses. This is a shift up 3. Okay, so the right side of your graph, Angel, is telling you what has happened to the parent function. So if there's a number in front of x, that means it's either a shrink or a compression. If there's a number just added to the end like this, that means it's going up or down. And if there's a number inside the parentheses, that means it's going left or right. So it's backwards from what you would think. If you're adding something in the parentheses, you're actually going left. If you're subtracting something in the parentheses, you're going right. I'm going to show you, but before I do, I want to post this for you because I think that if you take a picture of this, this might help you. So these are like our rules for transformations. Take a picture of this because you can use this on your homework, on your test. Okay. Horizontal shifts are when we have the function inside the parentheses, we're adding or subtracting something. That means we're going left and right. If what we're adding or subtracting is after the parentheses, that means we're going up or down. Okay, good, Jonathan. So you can take a look at your function. So let's say you were given a problem that said, okay, g of x, man, why is my mouse not working? That's a g. G of x equals x minus 1. Okay, so I would ask myself, what does this look like? looks like this. Okay. Parentheses, x minus 1. So that means that must be going to the right 1. All right, so what I want you to do now, I'm going to post the link again because what we're going to do is we're going to take 10 minutes. Erica, do you still have your question? Okay, let me unmute you and you can ask. While Erica's asking her question, I need everyone to open up this class kick assignment because we're going to go over some of this all together because there's going to be times where we can combine more than one transformation. So I want to go over that with you. Okay, Erica, go ahead.
So for my question, like during the test, I got confused on the shifting part because I didn't really like I watched a video of the shifting, but it was like still confusing. So if it's in parentheses and you're adding or subtracting, you go left and right, and then if there's no parentheses, and it says like f of x plus like 5 or something, is it up or down? Like you do it
Correct.
up or down?
Okay. That's correct.
And for the stretch and compress part, I didn't understand any of the stretch.
Okay,
Part.
it looks like you got it 100%.
Yeah, I did.
Okay.
I just tried my very best because I looked on a review just to for my first attempt. I just to help.
Okay, well we're gonna do some practice problems here in Class Kick, so maybe that will help clarify and solidify some things. Okay.
Okay.
All right, so if everyone could go to the Class Kick assignment. I'm going to put this assignment in Neuro just so that I can also be helping you. Okay. So let's look at, we're not doing any of those. Use the link I just gave you. So this is not, it hasn't been assigned to you because I didn't want you to think that this was homework that you had to do. This is just for us to work on together. Okay, so Mia. Yes, that's exactly right. All right, so I want everyone to look at number 1, where it says g of x. We're going to take this one step at a time, and it's saying describe the transformation. So we're just going to write out in words what is happening. So the first thing that we notice is this negative sign outside the parentheses. So if I go back to my rules, when the negative is outside the parentheses, it's a reflection across the x-axis. So I'm going to first write reflected across the x-axis. Okay, and I got that because I saw that there was this negative sign out in front. Let's undo that. The negative sign out in front. When I look at my rules, if the negative is out in front, why is my mouse being silly? That's a reflection across the x-axis. All right, let's see what else is happening. Inside the parentheses, I have plus 5. If I go back to my rules, inside the parentheses is going to be left however many I'm adding. Since I was adding 5, that means I am shifting to the left 5 units. So all you're doing is listing what is happening. You're saying, okay, this new function was reflected across the x-axis and shifted to the right 5 units. Okay, so write that down or type it out if you have not yet for number 1. And let's work on number 2. So again, we're going to take it one step at a time. First thing I notice is this 2/3. Okay. 2/3. Okay, so let's go back to our rules. For our slope, okay, if A is between 0 and 1, that is going to be a compression or a shrink. Okay, so then I can go back and say, okay, this function had a compression of 2/3. Okay, or if you want to use it was shrunk by 2/3, that's totally fine. And then what's happening? We have this -4 at the end. It is not in parentheses. So let's go back to our rules. Subtracting 4 at the end means we're shifting down. So it's a compression of 2/3 and shifted down 4 units. Questions so far? All right, let's try number 4 because it has 3 different things happening. Okay, good. So number 4, and I just put this up here so y'all could practice on your own. So if later in the day you want to do all of these problems and you want me to check it, I can try to check it before the end of the day, just to make sure that you've got it. So let's look at number 4. The first thing we have is the number 2, which would be like outside. That's our slope. So if our slope is bigger than 1, that's going to be a stretch by 2 units. The next thing I have is a +1 inside the parentheses. So I stretch it by 2 units. I'm going to shift to the left 1 unit. And the last thing I'm going to do, subtracting 10 at the end, means I'm going to shift down 10 units. Okay, so it was stretched by 2, move to the left 1, and then down 10. Okay, I want to do one more on this page. Let's do number 8. So the first thing I notice is this little negative sign. If I go back to my rules, the negative sign outside of the parentheses, it's not -x inside the parentheses, it's a negative outside. So that's going to reflect across the x-axis. So first I have a reflection across the x-axis. Then I have that number 4. Okay, so 4 is greater than 1. So that's going to be a stretch by 4 units. Inside the parentheses, I have this x minus 2. Since it's inside the parentheses, that means it's moving left and right. So this is going to be shifted to the right 2 units. And then lastly, at the end, we're subtracting 4, which means it's going to be shifted down 4 units. So my advice to you when you're doing these is to just start at the beginning and take it one transformation at a time. So anything that's different means it has been transformed. So if it's now negative, that's a reflection. If the slope has changed, it's a vertical stretch or compression. If there's something in the parentheses, it's left or right. If there's something at the end, it's up or down. Okay, so don't try to look at all of it at the same time and write it all. Just go one piece at a time. One piece at a time. Okay, I want to real quick show you how to do the ones at the bottom or on the second slide of yours where you have to write the rule yourself. That is so tiny. What's going on? Okay. Well, let's do this. Number 11, if you'll look at number 11, it says to reflect across the x-axis. Okay, if I go back to my rules, reflect across the x-axis just means we're putting a negative out in front. So this means that g of x would equal negative x. That's it. That's all you have to write. We put the negative out in front. Yeah, Jonathan, or you can do negative f of x. That's fine. Totally fine. We're taking the original function and making it negative. So for number 12, vertical stretch by a factor of 4. Okay, where do I see vertical stretch on here? Stretch vertically. Okay, so what does that mean? It means I take the number and put it in front of either f of x or x, whatever you want to write in there. So that means my new function, g of x, would be 4 times x. Or if you wanted to write it as 4x, that's fine too. Angel, we're working on the word problems now. So on slide 2. Let's go to another one. Let's do number 15 because I want to do some where we have multiple steps. So for 15, it says to reflect across the x-axis. So you can do this one step at a time. Reflect across the x-axis. Okay, and translate 3 units left. So that would be reflecting across x. Then if I wanted to go 3 units left, I would still have my negative, and I'm going to put this plus 3 inside the parentheses. Okay, so you can do it one step at a time. Actually, let's do number 18 together to finish off. So number 18 says, all right, you've got a vertical stretch by a factor of 2. So that means I'm going to have a 2 out in front of my x. Okay. Translated 7 left. Okay. Left, when I'm moving left and right, is like the opposite. I know left we want to think negative, but it's actually, we're going to add. So I'm going to do plus 7 in the parentheses. It also tells me I'm going up 4. So I have to add 4 outside the parentheses. And then reflect it across the x-axis. So that's going to be a negative out in front. So hopefully that helps and you can make a little more sense of it. That's all that I have for you today.